So over this module, you'll learn a lot about the advanced things you can do with Redux. Especially action creators and middleware are key things since they allow us to run async code when dispatching our actions. Now, I want to dive into advanced reducer setups. Right now we have two reducers. It's a bit advanced because we already split it up and use combined reducers. But each reducer still has a relatively long switch statement. And even when breaking up your reducers into multiple files, you probably still have relatively long switch case statements for each reducer, at least if it handles more than two actions. So cleaning up that reducer file a bit more can be an idea. And I say can be. It's not a must. It's optional. It's a good practice, I'd say, but you don't have to do it. I want to show you some ways of cleaning up this reducer step by step though, to end up with a very clean reducer. Again, what I show you is optional though. So the first thing we can do is related to immutability. We constantly update an object here in the end. Whenever we return a new state, what we do is we just return an updated object. We return an object which copies the properties of the old state and then replaces one of the properties. Now, obviously, we can absolutely do it like this, but we could create utility functions for that, and the same for updating arrays. This would then allow us to call this utility function and save some code here. How could this look like? Well, let me show you. For that, I'll create a new file, which I'll name utility. And I'll store that in the store folder. You could store it in the reducers folder, but I don't want to have this file look like it was a reducer. And you could store it in some other folder, but I'll use it in Redux only. So for me, the store folder sounds great. There, I'll create a function with the ES6 arrow function style. So I'll create a constant holding a function in the end, which I'll name update object. This function, again using ES6 arrow syntax, expects two arguments. The old object, which I want to copy and update, and the updated values. In this function, I then simply want to do what I previously did in my reducer. I want to return the updated object. So I'll copy one and return it in my utility function. Here, I first of all have to distribute the properties of my old object. So I'll create a new object with all the old object properties and values inside of it. And then there are some parts we will probably update. Now here, I knew that it would be the counter for the given reducer I pulled this from. Here it's updated values. And updated values in the end could just be a JavaScript object with all the values I want to override. So I'll also distribute that, updated values. So I expect updated values to be a JavaScript object here. This is my utility function to update an object. Now let me show you how you could use it. In the counter.js file, I'll import it. I'll import something from, and now I'll move up to the utility.js file. And the something I import, of course, is my update. And I should export it therefore. So let me add an export statement. So the something I want to import is my update object function. I can then use that to basically replace it whenever I want to update something. So in my reducer, I then just return a call to update object, where I pass the state as the old object, and then an object with all the new properties. In my case, an object with the counter property where the new value is state counter minus action val. And now it's a bit leaner due to this utility function. We can then do this for all our cases. So update object here also takes the state and then a JavaScript object where we update the counter. And I need to pass a JavaScript object because I distribute the values of this object across the copied old object in my utility function. So let me quickly do this for all the other usages here too, for all the other cases. Always update the state and pass a JavaScript object with the updated properties. So finally, last time I need to do this is here in my increment method. There I used the longer approach of updating my state previously. Now I'll use this very short and condensed approach of just returning update object. And there I want to increment the counter, so +1. Let's quickly save all files, including the new utility.js file. And let's see if that works. Click add 10, decrement. This all seems to work. So our app works as before. You can also still store this as you see, but now we're using the utility function. So with that, we're using update object to conveniently, update all our objects. Let's also do the update object usage or implement it in the result.js file, so in the other reducer. So I'll import update object from, and now also move up to the utility.js file. And then let's use update object here too, to return an updated object where we pass the state as the to be updated object, and then just a JavaScript object with the properties that should be updated. And this allows us to then get rid of the old code we had in there and use that shorter one. And the same, of course, also for delete result. Now there I'm also updating an array. I won't write a utility function for that, since updating an array depends highly on what we do with an array. Adding a new element works with concat, removing with filter, for example. So therefore it's not as easy as with an object, and a utility function doesn't make that much sense for that reason. But we still update an object here in the end. We always do when returning a new state. So there we get the old state, and then we want to override the results with our updated array. So let's pass this in the JavaScript object of the second argument. With that, let's save all of that, and let's also see that in action now. So this all seems to work. Let's store the result. Also works, deleting also works. So that's looking good. This is update object. This is a nice utility function we can add to make our reducers a little bit leaner.